Hey, good evening. What I want to talk about in this video is a common argument made by creationists, intelligent design advocates, whatever they want to call themselves, where they will try to debunk evolutionary theory by saying that this or that biological system or organ is irreducibly complex, right? So people making this argument will at least have a basic understanding of evolutionary processes like natural selection, right? Which can't be said of all intelligent design advocates. Many of them will have the impression that evolution is all just a matter of people saying that living things came to be set up so well by pure chance and that it was just nothing but chance and luck, which is a complete misconception. No one is saying that that's what it was a matter of, but that's a separate topic. If you haven't learned about that yet, this video isn't going to help you. But some people who at least understand the basics of how natural selection works, they will make an argument called irreducible complexity, right? And the way that this argument goes, right, is that they will say that certain biological systems or organs, certain features of living things, that they need to have all the parts in at once in order to work and have any use, or at least most of the parts, or else otherwise they're completely useless, right? And therefore cannot be explained by evolutionary processes. So to give you guys an example, the human digestive system, it is far more it is far too complex to come about in a single mutation, right? And so you couldn't just have something with no digestive system at all, just have a single mutation that causes it to have a digestive system like that of a human, right? So therefore, the digestive system could not come about in a single evolutionary step, right? And so if evolutionary processes can explain the digestive system, then it has to be in a series of many, many steps, right? Leading up to the digestive system of a human, if we're to, with evolutionary processes, explain how we go from something with no digestive system at all to something with the digestive system of a human, you need to have a series of steps, and each of those steps has to be useful in its own right. Otherwise, if each of these steps would not be useful in its own right, that would be a serious problem for evolutionary theory, right? Is there any way that we can test whether or not a biological system is irreducibly complex? In many cases, the answer is yes, right? So for example, going back to the digestive system, right? Not all living things even have a digestive system. I'm guessing you guys already know that. Plants don't have a digestive system. Bacteria don't have a digestive system. You don't need to have a digestive system in order to survive and reproduce. At least some living things don't, right? And then amongst living things that do have a digestive system, do they all have a digestive system as complex as the one that humans do, or nearly as complex? No. So, sponges, which are the most primitive known animals, they don't have a mouth or anus or gut, none of that, but they still ingest organic material through a process known as intercellular digestion, right? And then next, you don't need to have the mouth and anus come about in a single evolutionary step at once, because there are a few primitive groups of animals still alive today which have a single hole that they use both as the mouth and as the anus, right? So they eat through the same hole that they poop. It comes in through the same hole that it goes out through, right? And then also, in order to have a fully functional digestive system of any kind, you don't need to have a coelom, right? And the coelom, what that is the mesoderm-lined cavity between the gut and the outer body wall. And mesoderm, that is one of the primary germ layers in embryonic development that develop into all the different parts of the body, right? And so, flatworms, right? There's a few primitive animals like flatworms which do not have a coelom, right? But they still have a fully functional digestive system, right? But there's no space between their gut and their outer body wall. Their gut is fused to their outer body wall with no space in between, right? And then next, in order to have a gut at all, you don't need to have your gut specialized into differing regions like pharynx, esophagus, stomach, small intestine, large intestine. These various regions of the gut are not found in all animals that have a gut. To give you guys an example, monotremes, the platypus and echidna, they don't have a stomach, right? But they still have a fully functional digestive system, right? So you don't need to have it specialized. You don't have to have that specialized region, the stomach, in order to have a fully functional digestive system. And during your early stages of embryonic development, your gut tube doesn't, when it first forms, your gut tube doesn't have any of these specialized regions, right? Only later into development, after the gut tube forms, only later does it do different regions of it specialize into differing towards differing purposes, right? And furthermore, this is what else you guys might find interesting. The embryonic gut tube is also where we get the trachea and lungs from, right? So it's from that same tube. Once it specializes into different regions, a few of the regions that it specializes into are the trachea and lungs, right? And that is evidence that the trachea and lungs are evolutionarily derived from the gut tube. But for now, I'm going to stay on the topic of the digestive system, right? So furthermore, in order to have a fully functional digestive system, you don't need to have a liver or a pancreas. Invertebrates, which make up the vast majority of living animal species, they do not have a liver or pancreas, but they still have fully functional digestive systems. The fact that we have a liver and a pancreas, this is explained by the fact that we are vertebrates, right? And then in order to have a fully functional digestive system, you do not need to have jaws and teeth. The vast majority of animals do not, right? The fact that we do is because we are a part of a group called the gnathostomates, which is a group that includes the vast majority of living vertebrates, right? And then in order to have jaws and teeth, you don't need to have just one lower jawbone like is the case for humans. Most groups of vertebrates have many lower jawbones, but it is because we are mammals that we have one lower jawbone. That is one of the traits of mammals. And in order to have teeth, you don't need to have different shapes of your teeth one from the next. You don't have to have your teeth specialized into incisors, canines, premolars, and molars like is the case for humans. The fact that that's how it is for humans is explained by the fact that we are mammals, because that is again a mammalian trait. And the evolutionary transition to these traits, one lower jawbone and differing types of teeth, the evolutionary transitions to these traits is seen in the fossil record, right? And also it is because we are mammals that we have an epiglottis, right? But you do not need to have an epiglottis in order to have a fully functional digestive system, right? That's what we find when we look to most other creatures aside from mammals. And then in order to have a digestive tract with two ends, including both, one side for where you eat and another side for where you poop, two separate holes for that, you still don't need to have separate holes for where you poop and where you pee and reproduce. We know this because monotremes, birds, reptiles, amphibians, and many fish all have what's known as a cloaca, which is a single hole used for peeing, pooing, and reproducing. They do it all through one single hole. The fact that us humans do not have a cloaca is explained by the fact that we are members of a group known as the Therians, which is a group that includes the vast majority of living mammals, right? But Therians, still during embryonic development, start out having a cloaca, right? But then it typically divides into separate holes before birth for Therians. But even in the case of us humans, not only do we start out having a cloaca in our early stages of development before it divides into separate holes, in some rare instances, a person can be born with a cloaca. Although the vast majority of the time that a person is born, they don't have a cloaca. In some very rare instances, it does happen, right? And then next, in order to have differing types of teeth, including incisors, canines, premolars, and molars, you don't need to have the dental formula that us humans have. Dental formula, that refers to the number of each kind of tooth, so the number of incisors, number of canines, number of premolars, and number of molars. The human dental formula is 2123, 2123, but amongst mammals, we have very diverse, all types of differing dental formulas. The fact that we have the dental formula 2123, 2123, this is explained by the fact that we are part of a group of primates known as the catarrhines, right? So baboons, mandrills, macaques, gibbons, orangutans, gorillas, chimpanzees, bonobos, and humans, we all have the same dental formula, 2123, 2123, right? And one lower jawbone and an epiglottis and a pharynx and an esophagus and a stomach and a small intestine and a large intestine and an anus, which is a separate hole from where we reproduce and from where we pee. Well, yeah, and from where we pee, it's a separate hole, right? You know, they all share mostly the same digestive anatomy as us humans, right? Which is exactly what our evolutionary models would predict, but not all creatures do. As I just laid out, there's many varying degrees of complexity of the digestive system. You don't need to have anywhere near as complex a digestive system as us humans have to have a digestive system that works at all, is useful at all. And this is just a brief, summary of the evolutionary, the evidence in regards to the evolution of the digestive system. But if you guys are interested in learning more, it's not like this is the most comprehensive explanation you'll find. If you research it, you could find much more comprehensive explanations. But this should just give you guys a basic idea of how do we test, is a system irreducibly complex or no, right? All right, that's all for now. See you guys.